We are issuing an immediate security advisory for a severe vulnerability impacting Citrix NetScaler ADC and gateway perimeters. Tracked as CVE-2026-8451, this is a CVSS 8.8 pre-authentication memory overread. Operating as a direct successor to the highly destructive CitrixBleed exploit, it targets the boundary where your network handles external identity requests. The objective of this coordinated vulnerability disclosure is straightforward. Defenders must understand the mechanics of this flaw to force immediate patching before threat actors weaponize the primitive at scale. This timeline plots the rapid escalation. Disclosed on June 30th, it received a critical severity score immediately and triggered public alerts by July 2nd. We are inside the critical window. Historically, vulnerabilities in this class are reverse engineered and exploited within days of public disclosure. To receive real-time intelligence updates on this zero-day and emerging threats, subscribe to @cybertech79 and enable notifications. Acquiring this intelligence is the required first step in defending your perimeter. Situational awareness directly dictates the speed and effectiveness of your incident response against zero-day threats. Exposure to CVE 2026-8451 depends heavily on your firmware version. The flaw affects NetScaler ADC and Gateway 14.1 builds prior to 72.61, 13.1 builds prior to 63.18, and their respective FIPS and NDCPP editions. This topology map isolates the mandatory precondition. The vulnerability remains completely dormant unless the appliance is actively configured to act as a SAML Identity Provider. You can confirm this by checking your appliance configuration for the Add Authentication SAML IDP profile command, activating the vulnerable parser path. If configured solely as a SAML service provider, it delegates authentication to an external entity, bypassing the flawed XML parsing logic entirely. However, an active identity provider role inherently places the appliance in the path of untrusted external internet traffic, creating an unauthenticated attack surface. Relying on a firmware version check alone will result in a catastrophic operational failure. Defenders must audit the specific SAML identity role and external network exposure to calculate their true risk profile. The exploit targets the /SAML/login endpoint, which is responsible for receiving base64 encoded XML authentication requests from external clients. Rather than implementing a standard, heavily vetted XML parsing library to handle these requests, Citrix engineered a custom parser for this specific authentication path. This schematic illustrates the custom XML parser analyzing an incoming request. The critical flaw exists in how the parser attempts to define the boundaries of unquoted XML attributes, like the assertion consumer service URL. When unquoted, a safe parser stops at the next space. This custom logic ignores whitespace entirely, pushing the read pointer past the intended boundary. It continues reading adjacent memory indiscriminately, halting only when it encounters a null byte or closing bracket. Attackers exploit this by sending a deliberately malformed XML payload where the attribute is left blank and completely unterminated, forcing the system to read memory it was never meant to access. Bypassing standard software libraries for custom parsing transforms what should be a minor syntax error into a severe system-level memory disclosure right at the identity boundary. Once the unauthenticated attacker forces the memory overread, the appliance must return that data. This maps the internal memory buffer of the NetScaler Packet Processing Engine, or nsppe. The parser embeds the overread memory directly into the HTTP response. Specifically, the extracted fragments are injected into the outbound NSC task cookie, handing internal data straight back to the attacker. The leaked memory can contain internal process pointers. Attackers collect these pointers to bypass memory randomization defenses, which they can then chain with other vulnerabilities to achieve remote code execution. The exploit also carries a severe availability impact. Sending a minimal, malformed request to this endpoint reliably crashes the nsppe process entirely, resulting in an immediate denial of service. The original 2023 CitrixBleed vulnerability routinely leaked massive, kilobyte-sized dumps of session data. Because this new parser flaw halts at control characters, it typically leaks only a few bytes of memory per request. However, The combination of leaked process pointers and the ability to destabilize the authentication process makes this a highly dangerous foundational primitive for total appliance compromise. Remediation requires the immediate application of the official Citrix firmware updates referenced in Security Bulletin CTX 696604. Web application firewalls are incapable of fully mitigating this threat. A WAF might catch obvious malformed requests, but it cannot fix the underlying code executing on the appliance that terminates the protocol path. If immediate patching is impossible, you must apply temporary compensating controls. This means disabling the SAML IDP functionality if business operations allow, and strictly restricting external network access to trusted administrative IPs. For organizations operating high-availability NetScaler clusters, both the active and standby nodes must be patched. Leaving a standby node on older firmware exposes a vulnerable edge the moment a failover occurs. This graph plots baseline authentication traffic. SOC teams must actively hunt edge telemetry for anomalous spikes in /SAML/login requests, particularly when those spikes correlate with sudden nsppe process restarts. After patching, harden your configuration. Tighten your assertion consumer service URLs from broad regular expressions to exact matches to prevent secondary SAML abuse. Mitigation is a multi-layered requirement. Patching stops the active memory leak, but executing telemetry hunts and validating ACS rules are required to verify no compromise occurred prior to the update. We provide this technical disclosure because defenders must understand the exact exploit mechanics to properly secure their most sensitive identity boundaries. Executing public proof-of-concept codes against live production environments is incredibly dangerous. Testing this exploit on a live system can inadvertently crash the appliance and expose real user data. Security researchers have an ethical obligation to prove vulnerability exposure using authorized version checks and configuration audits, without disrupting production identity flows or causing localized denial of service. Mastering cybersecurity requires balancing the aggressive pursuit of threat intelligence with the ethical imperative to secure systems without causing self-inflicted damage to the perimeter. Stay secure.